If you look in your notes, we're on page 4 and we're looking at number 10. And the directions say to multiply and then write your answer in simplest form. Now look at the first step. The first step says to factor first. So here's the actual example that you were given. So what I'm going to do is I'm just going to break it down and we're just going to go like this. And I'm going to do like a blank set of fractions and then I'm going to basically factor each section. So I'm going to factor the numerator of the first fraction and I see that I can take out a GCF of 4 and when I do that I get x plus 2. Now if I look at the denominator of that same fraction I see that I have the difference of two perfect squares. So that's my dots. So that's going to be x plus 2 and x minus 2. All right, now let's look at the next fraction. In the top right, which is our numerator, I see that I have a trinomial. So I want to figure out what adds to positive 3 and multiplies to negative 10. So that's going to be two sets of parentheses, right? Okay, and that would be a positive 5 and a negative 2. Okay, x minus 2. So you see that a positive 5 plus a negative 2 will give me a positive 3. And when I multiply a positive 5 times a negative 2, I'll get a negative 10. All right, then we look at the denominator of that fraction, and I see that I do have another GCF. So I'm going to take out a 2 this time, and I get x plus 5. Okay, so now we have basically factored first. That's our first step. Now look at the second step down. It says cancel out any like terms. When we cancel out any like terms, you can only cancel any numerator, any factor in the numerator, with any factor in the denominator. Okay? So for example, I see an x plus 2 here, and I see an x plus 2 below it. So I know that I can cancel those two out. One numerator, one in the denominator. In the other fraction over here, I see that I have x plus 5 terms, one in the numerator, one in the denominator. I also see, remember it can be any numerator, any denominator, I see that I have a factor of x minus 2 and x minus 2. Okay? Now, last but not least, I do see that the constant terms 4 and 2, they have a common factor of 2. So if I take a 2 out here, I'll have 1, and if I take out a 2 here, I'll have a 2. So now, let's look at what it says. Step 3 says multiply across and rewrite as one fraction. Well, if we look at what we have left, the only thing we have left in all of these numerators here is just the 2. So that's what I'm going to have in the numerator. And then in the denominator, let's look, if I multiply across, the only thing I have left is a 1. Obviously, we can just simplify that, and that would just be 2, and there's your answer. Now, if I didn't already say so, but I am going to repeat myself perhaps, please make sure that you're taking notes in your notes packet on these questions. So now, why don't you flip to page 5 and look at number 12. Now this one's a little bit more complex. We have a negative exponent. What you have to try to remember about negative exponents is we can make them positive if we take the fraction and we actually take its reciprocal. Or, in simpler terms, we just flip it. So what that's going to do then is make that negative 2 power a positive 2 power, just like that. Okay? And then we just rewrite the second fraction for right now. Oops, let's make that look like a 2. N minus 3. And then this is m squared plus 4m plus 4. Okay. So now we've gotten rid of the negative exponent. Okay, now another way we can write that is when something is squared, like when 2 is squared, that's really 2 times 2. When 5 is squared, that's 5 times 5. So we write that number twice. So in this case, what we're going to do is we're going to write 3m plus 6 over 4n minus 12 times another 3m plus 6 over 4n minus 12. It's like double the fun. Okay, and then we kind of do the same thing where we just bring this down for the ride. Okay, so then we've got m squared plus 4n plus 4. All right. So now we're kind of starting off where we were with number 10. So we had a little bit of extra work to do here. Okay, now remember, go back and look at your steps. So the first step that we should do whenever we're multiplying fractions is to factor first. So we're going to start by factoring. So I like to do a blank set of fraction lines like that, and then I'm going to factor. So in my first fraction, I see in the numerator that I have a GCF of 3, so I'm going to take that out, and I get n plus 2. Same thing in the denominator. I have a GCF, this time it's a 4, and I get n minus 3. So obviously, since this is the same fraction as the first one, I can just copy down what I have there, and I would get n minus 3. All right. Now, the last fraction. Those are both trinomials, both in the numerator and the denominator. So we're going to do the AM method. What adds to what and what multiplies to what. Okay, so in this case, if we're looking at the numerator, we're trying to figure out what adds to 2 and multiplies. I guess my stylus doesn't seem to want to work there. To 3. Okay, and the same thing down here. What adds to 4 and multiplies to 4. Okay. All right, so let's look at the numerator. So that would give me n minus 3 and n plus 1. Okay, and in the denominator there, I would get m minus 2. I'm sorry, plus 2, plus 2, plus 2. There we go. And m plus 2. So once we have it fully factored, now we're going to look at this, and remember, go back and look at step 2, and step 2 tells you to cancel out any of your like terms. Remember, any numerator with any denominator, that's the rule. So I see an m plus 2 over here, and I see one way down in the last fraction's denominator. Same thing with the second middle fraction, an m plus 2 and another m plus 2. I see an n minus 3 and an n minus 3. And I think at this point, if you take a good look, I don't see any other common factors that we can cancel. All right, so then that being the case, remember the last step is to multiply across and rewrite as one fraction. So if we look, then what we have here, we have a 3 times another 3 times the n plus 1. And then in the denominator, we have 4 times 4, oops, bing, and times the n minus 3. Okay? All right, so then what we're going to do is we're going to do 3 times 3, which is going to be 9, times the n plus 1. And then in the denominator, we're going to do 4 times 4, which is 16, times the n minus 3. Now I always kind of do a double check here and just look to make sure, did I miss anything? Like, does anything go into 9 and 16, which there isn't besides 1. And n plus 1 and n minus 3, well, those don't cancel out either. And so then if that's the case, there's your answer. All right, so turn to page 6 in your packet. Again, you should be keeping notes in your packet. We're going to look at number 15. Now, this is a little bit different, nothing too crazy, but if you read the directions, again, we're going to be dividing this time instead of multiplying. Well, actually, in this question, we're going to be doing both. And you're going to write your answers in simplest form. Look at step 1. It says keep, change, flip. So we've been doing multiplication in the prior 2 questions, so nothing's going to change there. So all we're going to do is we're just going to drop down those first 2 fractions. Now I see division. When it says keep, change, flip, what it means for you to do is we're going to keep anything that's multiplication, or we usually keep the first fraction. In this case, we have 2 fractions that are being multiplied, so we just leave those alone. Now it says change. So what we're going to do here is we're going to take this division and we're going to change it to multiplication. That's what, when it says keep, change, flip, we're keeping all of this. We're changing that division to multiplication. And when it says flip, what we'll actually be doing is taking the fraction that comes after the division sign, and we're going to be flipping it. So in other words, what's in the denominator is going to come up to the numerator. Let's make that look like a plus sign. And then what's in the numerator is going to go straight down to the denominator. So now what we have is we have an example of all multiplication. So now we can follow all the rules for multiplication, which is to factor first, cancel any numerators with any denominators, and multiply numerators with numerators, and then denominators with denominators. All right, so here we go. So here's my little blank fraction thingies. It's a very official name. And then what we're going to do is we're going to factor. So x squared minus 9, well, I know that's the difference of two perfect squares. So that's x plus 3 and x minus 3. All right, let's look at the denominator. I see that I have a GCF. That GCF is an x, so I'm going to take that out. And I get x minus 5. Okay, the numerator of the middle fraction, that has a GCF as well. That's also an x. And when I take an x out, I get 5 minus x. Okay, the denominator is am. So what adds to negative 1 and multiplies to negative 12? So that would be x minus 4. Oops. And x plus 3. Okay, and the last fraction, the numerator, also is am. What adds to negative 8 and multiplies to 16? So that would be what? X minus 4 and another x minus 4. Okay, and then the denominator actually doesn't need to be factored. So here we go. All right, so then remember, we're really doing a multiplication problem now. So we're going to cancel any numerators with any denominators. So let's see what I've got here. I see an x plus 3 and an x plus 3, x minus 4 and another x minus 4. Oh, here's another x minus 4, and there's another x minus 4. Now we need to take a look just for a second here at something kind of important. All right, so let's look at this x minus 5 and that 5 minus x. They're opposites of each other. Look over here. This x is positive, this x is negative. That 5 is negative, that 5 is positive. When that happens, we can cancel them out. But remember, whoopsie, we need to multiply by negative 1. So what we'll do is you can take that negative 1 and you can place it in the numerator or you can place it in the denominator. It doesn't really matter. So I'm just going to stick a negative 1 right here. Okay? And by multiplying, for example, this factor here by negative 1, what it does is it changes it to x minus 5. So, and the reason why we want that is because then what will happen is it will match this x minus 5. So if I multiply this negative 1 through to this negative x, that becomes positive x. And that negative 1 through to this positive 5, it becomes negative 5, which matches this factor, and that's why we can cancel that. Okay? All right, so let's see what we have left, because we're going to multiply numerators with numerators and denominators with denominators. Well, I see I have that negative 1, and I have a factor of x right here, so I'm going to make that negative x. And then the only other thing I have left in that numerator is an x minus 3, right? Okay, let's look at the denominator. I have a factor of x and, well, nothing else. Now, I did this on purpose. Did anybody see what I didn't do? I could have, if I wanted to, I could have just taken these x's right here and canceled them up here, this factor of x and this factor of x. But I wanted to show you that because sometimes you just don't see it right away. So in this case, I do see it right away now. So what I'm going to do is I'm going to cancel out that x and I'm going to cancel out that x. Now remember, that does not get rid of that negative. So what we're going to do is we can just write that as negative parentheses x minus 3. Now you can leave your answer like that if you so choose. You could distribute it through and I would get negative x plus 3. So either one, this one or this one, is acceptable, whichever one you prefer.